So hello everyone, good evening to all. My name is Abhishek Pandey. I'm a Prime Minister Research Fellow in the discipline of Mathematics at IIT Bhubaneswar. Today we are going to talk about week 10 assignment. So let us start. So basically week 10 assignment is basically about the residue and meromorphic functions. Okay, so let us look at the first question. So it is saying that if if the residue of a function f at a point z not equals to 0, then z not is a removable singularity of f. Okay, so let us start this one. Solution. So let f such that omega to c is meromorphic. Meromorphic, and basically z naught belongs to omega. So fz has a Lorentz series expansion. So fz can be written like this: z minus z naught to the power n its Lorentz series expansion about z is equals to z naught. Okay, so basically what is the residue? So residue of f at z naught is basically a minus 1, which is that is the coefficient of 1 upon z minus z naught. Hello.
Yes, sir.
Dasana, is it visible to you? I mean, the screen is moving.
Yes, sir.
Okay, wait.
Yes, sir.
Okay, so this is residue of f of z naught. It is clear. Can you see a minus 1?
Sir, voice is not clear.
Yeah. I think some problem is going on with network. Yeah, it came. Now is it fine?
Yes, sir.
Okay. So the first option is if residue.
Yes, sir.
Yeah. So if residue of function f at point z naught equals to 0, then z naught is a removable singularity. Hello, voice is coming properly? Hello, Darsana?
Yes, sir.
Voice is coming properly, or?
बीच में साउंड नहीं सुनाई दे रहा, सर क्लियर नहीं है इतना।
ओके ओके ओके। So whatever I am writing, it is not visible, na? So whatever I am writing, it is not visible.
विजिबल है सर।
Okay, visible. Okay, fine. So first option is false. So first option is false. So first option is you can take fz is equals to 1 by z square. So residue of f at 0 is what? Is 0, isn't it? But 0 is a pole. Is it clear?
यस सर।
So first option is not correct. Now let us look at the second option. So if z naught is a removable singularity of f, then residue of f at z naught equals to 0. Okay, so second option is true. Like okay, so basically if z naught is a removable singularity, so if z naught is a removable singularity, then an is equals to 0 for all n is less than equals to minus 1. That is a minus 1 is equals to 0, and hence residue of f at z naught is basically 0. Okay, now let us look at the third option. Second option is true. So third option is saying if g is
Sir,
an
if I have another function g,
yeah yes Darshana.
if I have another function g, ओके, तो रेसिड्यू ऑफ f into g क्या होगा पॉइंट जीरो के आगे?
हाँ वो अभी हम लोग डिस्कस करेंगे नेक्स्ट ऑप्शन में. ओके ओके दर्शना.
हाँ यस सर।
So the third question is if g is another meromorphic function, then what can we say about residue of f into g at z naught? Okay, so basically what you can do, you take fz is equals to 1 by z, and gz you again take 1 by z. Okay, so f into g of z is nothing but 1 by z square. Residue of f at 0 is nothing but 1, and residue of g at 0 is nothing but 1. But residue of f into g at 0 is equals to 0. Is it clear to you, Dasna?
No, yes, sir.
Yeah, so this option is also false. Fourth option. So fourth option is about f plus g, residue of f plus g. So basically residue of f plus g at z naught is equals to residue of f at z naught plus residue of g at z naught. Okay, so this option is true. Let's see. So let f and g have a Lorentz series expansion as now f plus g have a Lorentz expansion as so residue of f plus g at z naught is basically equals to a minus 1 plus b minus 1. Hello?
सर आवाज नहीं आ रही है हाँ हाँ यस
This is clear? So basically, hello, voice is coming?
यस सर
So let us look at the fifth option. So suppose that S is a compact set contained inside omega, then F has at most finitely many singularities. Okay, so this is also true. See now. So fifth option is also true. Let S is compact S is a compact set in omega. Audio is clear to everyone?
सर नई लिंक जनरेट कर दे क्योंकि आवाज अभी इतनी क्लियर नहीं आ रही
Okay, I think some network issue is there.
Okay, sir.
Okay, so let S is a compact set in omega. Okay, and suppose F has infinitely many singularities. Sorry, in S. Okay, say Zn. So Zns are all the pole. Hello, is it visible? Yeah,
Yes,
so
sir.
Zns are pole. And now since S is compact, S is compact, so Zn has a convergent subsequence. Say Z and K converges to Z naught. So Z naught will be in S. Okay. So now, so at Z naught, F is either analytic or has pole. Okay, but both the cases are not possible. Is it clear to you? Is it clear to everyone? So basically the fifth option is about, suppose that S is a compact set contained inside omega, then F has at most finitely many singularities inside S. Okay, so so we have assumed that suppose F has infinitely many singularities. Okay, so assuming that, we got a contradiction. Is it clear to everyone?
Yes, sir.
Okay, now let us look at the second question. So we have to evaluate the integral under 2 pi I minus infinity to infinity 1 upon x to the power 4 plus 1 dx. Okay, so this we need to evaluate. Now if f of z is nothing but 1 upon 1 plus z to the power 4, okay, so then f has its pole the fourth root of unity. The fourth roots of my, sorry, not unity, minus 1. Okay, and these are e to the power iota theta, where theta is nothing but pi by 4 3 pi by 4, 5 pi by 4, and 7 pi by 4. So to calculate this integral, we are going to use the residue theorem. Residue theorem we will use. So, an is equals to exponential of hello, audio is clear?
सर वॉइस इज नॉट क्लियर बट स्क्रीन में दिखता है तो चलेगा.
Okay, so an is like this. Okay, and each an is a simple pole. Is a simple pole of f. Okay, so now we need to calculate the residue of f at a1. Okay, so this is nothing but, since a1 is a pole, a1 z minus a1 into f of z, and this is nothing but 1 upon a1 minus a2, a1 minus a3, and a1 minus a4. Okay, which is 1 upon, so e to the power iota pi by 4 minus e to the iota 3 pi by 4 to the iota pi by 4 plus e to the iota 5 pi by 4 e to the power iota pi by 4 minus e to the power iota 7 pi by 4. Okay, once you calculate this one, this you will get 1 upon minus 2 under root 2 plus I. Okay, and similarly, once you calculate residue of f at a2, the same thing you have to do. So basically this will be, limit is z tends to a2, z minus a2 into f of z, and this is nothing but 1 upon a2 minus a1, a2 minus a3, and a2 minus a4. Okay, so this you will get after calculating 1 upon 2 root 2 plus 2 root 2 I. Okay, now what we need to do is, now let r is greater than 4. A1 is what? E to the power. do here is, let r is greater than 1. So this is your origin, this is your 1 minus 1, and this is your r. Okay, now construct the half circle. Okay, and you call it gamma as, so over this and this. So a1 and a2 will be somewhere here. Okay, so now let r is greater than 1, and let gamma be the closed path which is the boundary of the upper half of disk of radius r with center 0. Okay, so by residue theorem, we have 1 upon 2 pi I integral over this gamma fz dz is basically will be equals to residue of f at 1 a1 and residue of f at a2. Okay, so this is nothing but, once you once you calculate, you will get 1 upon minus 2 root 2 plus 2 root 2 I plus 1 upon minus 2 under root 2 is 2 under root 2 of I. Okay, what is this? This is not minus. Okay, so this you will get 2 under root 2 plus 2 under root 2 plus 2 under root 2 I, and this you will get, okay, 4 under root 2 I minus 16. So this you will get minus I by 2 under root 2. Okay, so 1 upon 2 pi I integral over gamma fz dz is minus I by 2 root 2. Okay, now basically this integral you can separate. Okay, basically you can write 1 upon 2 pi I integral over gamma fz dz as 1 upon 2 pi I integral minus r to r fx dx plus 1 upon 2 pi I integral 0 to pi of gamma dot t dt, where gamma of t is what? R e to the power iota t, where t is running from 0 to pi. Okay, is it clear? Is it clear to everyone? Please let me know.
Yes, sir.
Okay.
नो सर, ये 0 to pi कैसे लिया? माइनस r to r फिर 0 से pi.
ये जो है गामा, ये बेसिकली ये दिस यूनियन दिस है, ओके एंड ये जो चीज है ये सर्किल का अपर हाफ पार्ट है। इसमें थीटा कहाँ से कहाँ तक वेरी कर रहा है, 0 to पाई।
Yes, sir. Yes, 0 to pi and नीचे minus r to r.
Yeah.
Okay.
Okay, so basically minus r to r 1 upon 1 plus x to the power 4 dx is nothing but 2 pi I. Okay, so what is the value of this one integral? So we will put this one. Okay, so minus I upon 2 under root 2 minus 1 upon 2 pi I integral 0 to pi f of gamma t gamma dot t dt. Okay. So this will be equals to, so this will be pi by root 2 minus, now r I into t dt 1 plus r to the power 4 e to the power 4 iota t. Is it clear now? Hello, this thing is clear?
Yes, sir.
Okay. Now for t is in between 0 to pi, 1 plus r to the power 4 e to the power 4 iota t lies on the circle of radius r to the power 4 and centered at 1. Okay, hence okay, now integral IR e to the power iota t dt 1 plus r to the power 4 e to the power 4 iota t, this basically less than equals to pi r square upon this is clear. So basically what we will get, so integral minus infinity to infinity dx upon 1 plus x to the power 4 is equals to pi by root 2 minus limit r tends to infinity minus r to r, sorry wait, okay. So this is nothing but limit r tends to infinity minus r to r dx upon 1 plus x to the power 4. Okay, So once you take r tends to infinity, this quantity goes to 0. Okay, thus integral minus infinity to infinity dx upon 1 plus x to the power 4 is basically equals to pi by root 2. Okay, so this implies under root 2 by pi integral minus infinity to infinity dx upon this is equals to 1. Is it clear to everyone?
Yes, sir.
Yeah, so this integral value is 1. Okay.
Sir, but I have one question.
Yeah,
Residue
please.
of f into g है ना, आपने बताया कि रेसिड्यू f into g f g है, तो वो रेसिड्यू f into रेसिड्यू g नहीं हो सकता,
नहीं,
तो क्या हो सकता है?
वो डिपेंड करेगा फंक्शन किस टाइप का है, बिकॉज f इंटू जी का जो
तो
लॉरेंट सीरीज
एक्सपीरियंस
एक्सपेंशन है,
कैसे उसमें?
हेलो,
हाँ, यस सर.
हाँ, f इंटू जी का जो लॉरेंट सीरीज एक्सपेंशन है उसको हम लोग f और g के कोफिशिएंट में कैसे लिख सकते हैं उसके ऊपर डिपेंड करेगा. ओके, लाइक f प्लस जी में लॉरेंट सीरीज एक्सपेंशन जो है वो सेपरेट हो जा रहा है. ओके, so basically once you take f plus g, so this Lorentz series expansion you can separate in terms of an plus bn. Okay, so where an is a coefficient of f and bn is a coefficient of g. Okay, so once you do for f into g, there is some particular formula for this one. I'm unable to recall it, but you can basically go through the Conway book. I think it is given in the exercise chapter for f into g for a special kind. I mean, not in general. Okay. Hello.
Yes, sir. But suppose f has isolated singularity at z0 and g is holomorphic, तो उस केस में हम कैसे लिख सकते हैं रेसिड्यू ऑफ fg?
Okay, so you are saying, just wait. Let me write down the question. So your question is f has, can you please repeat?
F has removable singularity at z0.
F has, okay, so not removable because it is again that one. So f has isolated, say. Okay.
F has isolated singularity at z0.
At z0, then.
And g is holomorphic.
Okay, so okay,
And
okay.
g is holomorphic.
Okay, G is holomorphic.
Yes.
Okay, then what is the question?
So what is residue of fg?
Okay, nice. So you have
And
to calculate the
if
residue
f
of
has removable singularity. Sir, f has removable singularity at z0.
f has removable.
हाँ, removable and second case is pole. तो उसमें हम कैसे लिख सकते हैं?
Oh, okay, you are dividing like a case. Okay, so f has in general f has isolated singularity. Okay. Hello.
Yes, sir.
Yeah, so this will be G at Z naught into residue of F at Z naught.
बट सर ये जी जेड नॉट इज नॉट इक्वल टू जीरो या इक्वल टू जीरो, कुछ कंडीशन होगी ना उसमें?
किसमें? No, so
ये
basically
जी
F
जेड
has a
नॉट के
singularity. So basically F has a pole at Z naught, and basically G is analytic in an open set containing Z naught. Okay.
ओके.
Yeah. So residue of F into G at Z naught is nothing but G of Z naught into residue of F at Z naught.
बट सर इन बोथ केस इफ एफ हैज रिमूवेबल सिंगुलैरिटी एंड पोल, बोथ केस में हम लोग लिख सकते हैं.
No, this is for pole.
दिस इज फॉर पोल.
Yeah.
अच्छा, एंड पोल ऑफ ऑर्डर एम हो तो उसके लिए क्या लिख सकते हैं?
No, वो डिपेंड नहीं करेगा. मतलब अगर F पोल ऑफ ऑर्डर M है. हेलो.
हाँ यस सर.
हेलो. अगर पोल F पोल ऑफ ऑर्डर M, ये जो मैं लिख रहा हूँ वो दिखाई दे रहा है ना? इज इट विजिबल ना?
यस सर.
या सो सपोज F अगर पोल ऑफ ऑर्डर M है तो उसको तुम ऐसे लिख सकते, वी कैन राइट लाइक दिस into Hz. Okay, then Fz into Gz is nothing but, hello, yeah, anything? Hello.
हाँ यस सर.
Yeah, so agar F has a pole of order M at Z naught, so basically Taylor series expansion, for that one A minus M is 0, isn't it? Hello. So basically once you have a pole of order
हाँ
M, so basically residue of F at Z naught is basically 0, isn't it?
यस सर.
That will be 0 residue. So here you will get 0. Is it clear to you or not?
सर क्लियर, बट ये रिमूवेबल सिंगुलैरिटी के लिए नहीं लिख सकते? सपोज एफ जेड इक्वल टू साइन जेड अपॉन जेड है.
Okay, so Fz equals to, so suppose F has a removable singularity as Z naught, and G also has and so G is holomorphic. Okay, so F into G will also have a removable singularity as Z naught. So residue of F into G at Z naught
ऐसे
will be
कैसे
0.
हो सकता? नहीं नहीं सर, सपोज एफ इक्वल टू साइन जेड अपॉन जेड है.
Okay, so let Fz
एंड
is equals
सीपी
to,
जेड फंक्शन है जी जेड.
yeah,
तो
Gz is Z, then
जी जेड इज इक्वल टू जेड है. ओके, सो एफ इंटू जी करेंगे तो साइन जेड होगा ना?
yeah, sin Z. So sin Z also has a removable singularity at 0, and basically it is analytic.
हाँ यस.
So what is the residue now? Residue
तो
will be 0.
रेसिड्यू इज जीरो. ओके.
Yeah, so if F has a removable singularity and G has a removable singularity, so basically F into G also has a removable singularity. So in
ओके.
in this case residue is 0.
Yes, sir.
Yeah, clear? Let me remove this one. Okay, so let us move toward the question number third. So here your fz is nothing but summation n equals to 1 to infinity 1 upon 2 to the power n z minus n. Okay, so basically it has poles at z equals to n. Okay, so what will be the residue of f at n? So this will be basically nothing but so first observe that this pole at z equals to n is simple pole. Okay, so this will be nothing but 1 upon 2 to the power n. And for other points it will always be 0. So summation residue of f at z where z belongs to c is nothing but summation 1 upon 2 to the power n. And this is nothing but 1. So our answer is 1. Is it clear? Hello, is it clear to everyone?
Yes, sir. Yes, sir.
Okay. So now let us look at this fourth question. So the given polynomial is z to the power 16 plus 1 upon 2 z to the power 7 minus 1 upon 3 z to the power 5 plus 1 upon 12. Okay, so you write, so here we will use the Rauch's theorem. Okay, so it is asking number of roots in the unit disk. Okay, so now you calculate mod of p to z. So this will be less than equals to 1 upon 2 mod z to the power 7 minus 1 by plus 1 by 3 mod z to the power 5 plus 1 by 12 on mod z equals to 1. So this will always be less than 1, and less than 1 is nothing but mod of p1z. Okay, on mod z equals to 1. So by Rauch's theorem, we have zeros of p1 plus p2 is equals to number of zeros of p1 in mod z is less than 1. So z of p is nothing but 16. So the answer is 16. Is it clear? Hello? Is it clear to everyone? Hello? Please let me know. Anyone, please let me know.
Yes, sir. But how we take this P1 and P2?
Okay, so here you have to observe. Okay. Okay. So basically, we want to show that once you see the coefficient of this p, so here you have to observe that this all the coefficients are basically less than 1. Okay. So my intuition is if I take p1 is this and p2 is whole this, and if if I take the modulus of this on unit circle, we will always get the modulus less than 1. Okay, so choosing P1 and P2 depends upon your some kind of observation. Okay, how your P looks like. Okay, there is no trick kind of thing, it is just an observation. Is it clear?
Yes, sir.
So let us look at the question number 5. So basically f of f is nothing but f dash z upon fz. Okay, so first option is f of 2f. So this is basically 2f dash z upon 2f. So this will come f dash z upon fz. And this is basically f of f again. Okay, so the first option is wrong. Okay, now you see the second option. So f of f plus g is will be equals to f dash z plus g dash z upon f plus g of z. Okay, okay, so this will not be equal to f of f plus f of c. Third one is you take f into g. So this will be f dash gz plus f into g dash z upon fz into gz. So this you will get. Okay, is it clear? Now the fourth option is, so second is not correct, third is correct. So the fourth question is, if f is a monomorphic function such that this is an entire function f of f, okay, then f is constant. So this is not true. We will construct an example. So let f of z is equals to e to the power sine z. Okay, and for fifth we will take fz is equals to e to the power pz. Pz. Okay, so option fourth and fifth are also not true. Is it clear? Hello? Is it clear to everyone?
Yes, sir.
Okay. Now let us move towards the question number 6. So here we will use argument principle. F of, so we need to calculate this integral. Okay. So we need to calculate this integral. So now by argument principle you know that this 1 upon 2 pi I f dash z upon fz dz is nothing but summation index of, so this is basically the index number of zk minus summation index number of gamma pj. Okay, so here gamma is given that circle centered at 0 and radius 11. Okay, so z is equals to 11. So this is your mod gamma. Okay, so now can you tell me what are the zeros? So these are counting multiplicity. Okay, so here we will get 1 plus 2 plus 3 plus 4 plus 5 minus 6 plus 7 plus 8 plus 9 plus 10. So this will be 15 minus 40 and you will get minus 25. So the answer is minus 25. This is clear? Darsana, Rajesh, Prakash, is it clear? So these all the roots are counting multiplicity. So basically one
Okay.
yeah, so index number of 1 will be 1, then index number of 2 will be 1, then again index number of 2 will be 1. So for index number 2 we have 2. Okay, so basically this summation looks like this. So wait, so index number of 1 1 plus index number of 2 is 1, फिर again index number of 2 is 1 because 2 is counting multiplicity 2. Okay, then again index number of 3 is 1, and since it is counting multiplicity 3, so we will write this. Okay, so combining this you will get this one, 1 plus this is 2, this is 3. Okay, so like this. Is it clear? Hello, any doubt?
ये सर एक मल्टीप्लिसिटी कैसे करते हैं z माइनस टू स्क्वायर है तो उसमें
या सो z माइनस टू स्क्वायर है तो 2 को 2 बार काउंट करेंगे, 2 को मतलब जब so when you are writing this summation, okay, so this is nothing but this summation eta sorry index number at zk is nothing but index number of gamma at z1 plus, तो ये जो है काउंटिंग मल्टीप्लिसिटी होगा. ओके, बेसिकली zk, so this is nothing but, so first zk is 1. Okay, so 1 का काउंटिंग मल्टीप्लिसिटी 1 है. Okay, now summation eta of gamma z के 2 2, लेकिन 2 दो बार आ रहा है इसमें. Okay, so 2, so multiplicity of 2 is 2. Okay, so we will count 2 times. So count 3 times. Is it clear now?
yes sir clear.
Okay, now let us move towards the last question. So basically F says that punctured unit disk to C is holomorphic. Okay, so now the first option is true. Basically if f of minus z is basically equals to f of z, so let us write the Lorentz series expansion of f. Lorentz series expansion of f is basically fz is summation n equals to minus infinity to infinity a n z to the power n. Now f of minus z is nothing but f of z. So f of minus z is what? N equals to minus infinity to infinity a n minus 1 to the power n z to the power n. This is nothing but a n z to the power n. Okay, so you will get a n minus 1 to the power n, a n equals to a n, and this implies a n is equals to 0 for all odd n, that is a minus 1 equals to 0, which is nothing but residue of f at 0. Okay, so option 1 is true. Now option second is false, since 1 is true. Okay, so for now option 3. So option 3, it is asking if you have this f of minus z is minus of f of z, then residue of f equals to 1. So that fz is equals to 1 upon z cube. So f of minus z is nothing but minus f of z. But residue of f at 0 is okay. So this option is also not true. Okay. Now let us look at the fourth option. So let A belongs to C. Define f of A of z is basically A by z. So that f of A minus z is basically equals to minus of f of az, and residue of f a at 0 is basically a. Okay, so this fourth option is true. Now fifth option is if f has a pole at z equals to 0, then the residue of f at 0 cannot be 0. Okay, so basically you just take fz is for this one fz is equals to 1 by z square. So 0 is a pole, 0 is a pole, but residue of f at 0 is 0. So we are done with the assignment. Any question? And sorry for this delay because some network issue is there. So if you have any question, please let me know. Hello?
Thank you, sir.
Okay.
Thank you, sir.
Okay. Yeah, thank you. So we will meet in the next session. Okay.
Thank you, sir.
Yeah, thank you everyone.